Welcome Pure Maths 1 students. We are looking at week 13 maintenance, and the first one today is a quadratic question. We're trying to find the values of k for which this equation has two equal roots. Now, two equal roots tells us that we need a b squared minus 4ac has to be greater than 0. So what we want to do is turn this whole thing into one quadratic. So I'm going to move things around here. Then we've got x squared, so that's our x squared term. We'll pull this across to the left hand side, so it'll be negative 4k plus 2 x plus 4k equals 0. Now, actually, before I pop this into my formula, I might just get rid of that negative there because that's going to cause some problems. So I'll say plus x, and then it's going to be minus 4k minus 2 plus 4k equals 0. And now we can chuck in our b squared. So b squared is going to be minus 4k minus 2 squared minus 4 times a. Now a is this. And then we're going to times it by c, which is 4k. And this has got to be greater than 0. So when we expand this, we'll get 16k. And then it's 16k squared, and then 4k times 2, so positive 8, positive 8, so 16k plus 4, and then when we expand the next bracket, it'll be minus 4k minus 8, and then that is going to be multiplied by 4k. So let's move over to here, and so we get 16k squared plus 16k plus 4 minus 16k squared minus 32k is greater than 0. Now let's see, that gets rid of that, and we get negative 16k plus 4 is greater than 0. So 4 is greater than 16k. So k, so that means, what is that, 4 over 16, 1/4 is greater than k, or k is greater than 1/4. There we go. Don't like that colour, let's move on. Okay, so we need to write an expression for the inverse, and then state the domain. So first of all, I'll just write it out like this. 3x plus 2 cubed minus 5. Okay. And then we're going to swap our x and y values. And then we are going to move that across to there, and I guess we can take the cube root of it. Now the next step is to bring the 2 across, so I'll have 3y is equal to negative 2 plus the cube root of x plus 5. And then we divide by 3. So y is equal to minus 2 plus the cube root of x plus 5 all over 3. And that gives us an inverse. So we need to write it in the correct notation like this, so don't just leave it with a y there. And the last thing we had to do is state the domain. So the domain is going to be equal to the range of the original function. So if you look at the original function, you can see that the lowest value it has is going to be when x is equal to 0. So you'd get, at f0, you would get 2 cubed, which is 8, take away 5, which is 3. And every other value is going to be more than that, because as you go above 1 and you cube it, you'll get a higher value, and you're taking away 5 from that, so it'll always be higher than 3. So for the domain, I would say, so that's the range. So if x is greater than or equal to 3, and therefore our domain for the inverse will be for x is greater than or equal to 3, because we swap our input and outputs over when we do an inverse. Okay, so this next one, we've got a rectangle, and what do we need to do? We've got some points, and we've got to find an equation of BC. Okay, well, the first step is gradient of AB. Change in y over change in x, which is 6 over 4, or 3 over 2. Therefore, since it's BC is perpendicular, gradient of BC is equal to the negative reciprocal. And now we can use our formula, because we've got b, so we can just go y minus y1. Now y1 is 8, equals, so this is our formula, y minus y1 equals m into x minus x1. That's the formula of a straight line. We chuck in our new gradient for the perpendicular, which is negative 2/3, and chuck in our next x value there. What we're going to get, y is equal to negative 2/3 x minus 4/3 plus 8. And that gives us finally y is equal to negative 2/3 x 32 plus 20 over 3. Okay, now the coordinates of C and D. Well, C's easy because this occurs when y is equal to 0. So all you need to do is take the equation of the line that we just found and say 0 is equal to negative 2/3 x plus 20 over 3. Then you can go 2/3 x equals 20 over 3. And 2x therefore equals 20. And then x equals 10. So coordinates of C are 0, 10. 10, 0. Now D. What we can do for this, we can just use the vector that we've transferred from B to C. So B to C is, you've dropped down 8 and you've gone across 12. So it's a minus 8. And therefore then A to D is the same. Therefore the coordinates of D must be drop down, go across 12, so that should be 14 for your x value, and drop down 8, so that should be positive 6 for your y value. Oakley dokley. Now we're on our second page, so we're on to circular measure. This is definitely not my favourite, circular measure. I always have trouble with this. Okay, now we've got this sector of a circle, POQ, so I'm just checking that out. Oh yeah, I see that, yep. And it's got a radius of 4, and then the arc length, the length of arc PQ, okay, is 7. Okay, that's cool. So we know that's 7. The lines PX and PQ are tangents. Lovely. And we've got to find POQ in radians. Angle POQ. Okay, so we know that this is 7, this arc length. Whoops, let's not write with the old highlighter. Now, if this is 7, we also know that the arc length is r times theta, and so therefore 4 theta must be equal to 7. Therefore, theta is equal to 7/4 radians. Now finding the length of px. Okay, well what we can now do is we can divide this into two triangles. We know that this is a right angle because it's a tangent. We know that this is 4. And we also know this angle here, instead of being 7/4, which would be the whole arc angle, we can say it's 7/8 because it's half of 7/4. So therefore, we can say, and we want px, so this is, we'll call this, well, we'll just call it px, won't we, right? It's px. And so we've got an opposite and an adjacent, so tan 7/8, now we want to be set to radians here, is equal to px, which we want to know, over 4. And then we just rearrange that to find px. Make sure you're set to radians. What do we get here? Tan 7/8, and then we multiply that by 4. I'm getting px is to be 4.79. Now, finding the area of the shaded region. Okay. That's my 3-year-old throwing a tantrum in the background, if you can hear it. She's not very happy about life. Okay. Well, the sooner you learn that, the better, hey? Okay, so what we're going to do is we are going to find the area of the two triangles, which would give us everything, right? It's going to give us all of this and all of this. So, the area of the two triangles is two lots of half times base times height. Now, we know what base is. It's the px. So, you probably want to save the unrounded number there. Px. And we want 2 of these. So, 2 times half px times 4. Half base times height. And then we're going to subtract the area of the arc, which is half r squared theta. So we end up with 4.79 rounded, but you use your unrounded number. I think it's like something like this, blah, 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 times 4, take away half, times r squared. Now r squared happened to be, what did we, r is 4, so 4 squared, and we know that theta, we found that out at the beginning, was 7/4. Now when we plop this into the calculator, we get, I'm getting 5.16 to 3 significant figures. That would be centimeters squared. Now, the next one is proving an identity. Now, in trigonometry, I know a lot of you struggle with this. Now, what we can do here is rewrite our tans as sine squared x over cosine squared x. So that's the top, and then on the bottom we've got 1 plus sine squared x over cosine squared x. Now at this point, I haven't really left myself much room. I'm going to make this one here and this one here have cosine squared x as a denominator. So I'll rewrite that as cosine squared x minus sine squared x over cosine squared x divided by cosine squared x plus sine squared x over cosine squared x. So this bit here is this bit here, and this bit here is that bit there. Okay, now at this point, just remember, just pretend that cosine squared x, this bit here and this bit here is like a 2. So we could say, you know, let's say we had something like x over 2, and then this middle line here is a divided by y over 2. Now what we do when we divide is we flip and do the reciprocal, and you can see that those 2's are going to cancel out. So those cosine squared x's are going to cancel out. Okay? So when they cancel out, what do we get? Well, we're just going to get cosine squared x minus sine squared x all over cosine squared x plus sine squared x. Now, you can still hear the tantrum going on. Okay, so this bit here is equal to 1. So we have a 1 there. And then we can replace this cosine squared x with 1 minus sine squared x. And I've already got a minus sine squared x there. And you can see that that gives me exactly what I want, which is 1 minus 2 sine squared x. Now the last question that we have to do today is we've got to do differentiation. We've got to find the value of a and b if there's a stationary point here. So first of all, we're going to dy dx this. So we get 2x. Now another way of writing a over x is a x to the power of minus 1. So when I differentiate that, I get minus a x to the minus 2. And then the minus b drops out. Okay? So therefore, if there's a stationary point at 2, that means when we insert a 2 in the value for x, so 2 times 2 minus a times 2 to the minus 2, that ought to equal 0 because the stationary point is when the gradient is equal to 0. So we get 4 minus, and another way of writing this is a over 2 squared, or a over 4, equals 0. So 4 equals a over 4. So a is equal to 16. Now that we know what a is, we can rewrite this formula that we've got all the way up here. We know that the y values is equal to x squared plus 16, because that's what a is, 16 over x minus b. And because we already know a point on the curve, we can chuck that data in. So we know that y is 12. We know that x is 2, so we just chuck all of the stuff in. And now we should be able to find b. So 12, take away 4, which is 8, take away 8. So it looks to me like b is actually equal to 0 anyway. The last part of this, let me see, I've really made a hash up of that. Okay, maybe I will just make this a bit smaller. Okay, now determine the nature of the stationary point. Well, what we're going to do is we're going to differentiate the gradient function. So we get 2 plus a x to the minus 3. And this is our second derivative. Okay, so this is, we write this like this. Now, all we need to do now is pop in this 3, which apparently is a stationary point. So I pop it into here. You go 2 plus, now a we said was 16, so 16 over 3 cubed equals, now what does that give us? 2 plus 16 over 27 gives us a positive number, 70 over 27. Now, since the second derivative is greater than 0, therefore this is a minimum point. Okay? And that's all that we've got this week. I hope that's been helpful to you. If you do have any questions or I've made any mistakes, let me know and we can chat about it. Alright then guys, take care.